post the website there again. All right, I'll wait one more minute here and then we'll get started. All right, great. Welcome everyone to week 2 of Practical R Workflow for Scientists. So up on the front here, okay. I just had a question, but I'm going to deal with. I'm going to wait. I'm going to pause. I'll break as I'm going along and have sections where I answer questions. Okay, so this is the website for the workshop, and today we're going to be going through this tab here, more Git plus coding. And as we go along, I'm going to be covering the material that's on this tab here. And then in the chat, you can post questions. And then when I stop, I'll go through the questions and I'll answer those a few times. And then at the very end, I'll stay on after the workshop and I can help you out, answer questions. Okay, so a few things from last week. Had a number of questions from people who were having trouble connecting up basically RStudio, Git, and GitHub, some combination of the 3 of those. Okay, so first comment about that. So in this workshop, I gave instructions of how to connect RStudio and Git. But when I normally teach this, I don't do that. I just use GitHub Desktop. The reason is like all the issues that I was dealing with the email, which was fine. I mean, I'm welcome to help you. That's what I'm here for, to help you out, to get you connected. But all the questions were about connecting RStudio and Git. Some of you worked really well, but quite a few you ran into trouble. And so that's kind of typical. If you use GitHub Desktop, usually it works pretty seamlessly. So if you're starting to get really frustrated, but you can get GitHub Desktop to work, that's totally fine. Just use GitHub Desktop. You don't have to use Git within RStudio. Second thing is on the setup here, on the setup tab, I added more instructions. And if you go down to help, I put in a bunch of questions that people, questions and errors people had. So if you're having trouble, go there on to help, see if the issue you're having has information. All right. Okay, so today, during this tab, we're doing more Git coding. And my topics, I'm going to do a little more Git, and I'm going to show you how to clone somebody else's repository. I'm going to show this with GitHub, but it works basically the same with GitLab. And then I'll talk a little more about some of the things that I'm not going to cover, which is like branches, merge conflicts, pull requests, that sort of thing. But I want you to see the workflow of how you work with GitHub, how you work with Git. Again, when I say GitHub, you can replace that with GitLab. Okay, so how do you clone someone else's repository? Okay. So one more comment about this. I'm going to show you a way that should lead to as little frustration as possible. I'm not going to show working with Git on the command line, because when you are starting out, that will lead to so much headache. So when you're starting out, the way I'm showing you is a way that should get you going without a lot of headache. Okay, so here we go. So I want to copy somebody else's repository. So this is what I do. So I'm going to go to a browser. Whoa, where's the browser? Sorry. Okay, I'm going to go to the browser and I'm going to navigate to the repository that I want to copy. Okay, so. All right, so this is the repository that I'm going to copy from. It happens to be an organization that I control. That doesn't matter. It could be anybody else. And now I'm going to go down to the one I want to copy. I click that. I then copy the URL. Now I'm going to go back to my own GitHub repository. I'm going to hit click up here, this plus. If you're in GitLab, it's going to be a green button in the same area that says like new project. And then I'm going to hit import. In GitLab, you're going to have, it's going to be similar language. It's going to say import. You're going to click that. Now you're going to paste in that URL. And now you need to give it a name. You can give it whatever name you want. I'm just going to call it. Is it available? Yes, it is. Okay, good. So that's it. Begin import. And it'll take a little time. Okay. While this is doing this, I'm gonna I'll make a comment on some things people posted in the chat. So somebody posted this great tutorial. I also linked to this a few times in the course material. It's Happy Git with R, and that's a really great place to start. And that's going to go into lots of details, especially if you're pretty familiar with kind of working around with computers. Don't get too frustrated. Then that's a really good place to start. I'm showing you a little bit different workflow, because I often teach these workshops to people who are not as familiar with programming, not as familiar with working on command line. And so my instructions are more geared to someone who's more familiar just with working with folders and stuff, clicking with buttons. And also to totally minimize the frustration factor in the beginning. Okay, so I think this should be done. Let me see if it's done then. Oh, it took so long. Okay, great. So now it's got tests. So now it's on GitHub. So this is the first step, is to get whatever you're copying onto GitHub, onto your GitHub and your GitLab account. So get it there first. And once it's there, out on the web, so out on your remote repository, then you pull it down. And if you follow that workflow, get it on the remote, then pull it down. You will minimize your frustrations in the beginning. Once you're all savvy, you can use a different workflow. But if you start with this one in the beginning, at least you won't drive yourself crazy. Okay, so now it's out there on my remote, so out there on the web, and now I'm just going to pull it onto my laptop. Okay, so how do I do that? So there are two ways you could do that. I'll show you one of them. So remember, I work with GitHub Desktop, so I'm going to show you how you're going to get that into that also, but I'm going to start by getting it into RStudio. If you're not going to use GitHub Desktop, just leave off the last step. Okay, so what I want to do is I go to my repository, okay, not the one I'm copying, my repository on GitHub, the one I copied. Say you're still putting it, that's not right. Let's see if this works. Longer than I thought. I'm copying the URL. I'm leaving off the import part because it. No, darn. That was unexpected. Okay, so now I've run into a little snag here because it's taking longer to import than I expected. So we're going to go back here, and I'm going to show you with this one, with new repo. So imagine that actually I'd waited longer. I don't want to wait now, but I would have to wait until it finished importing. And then I grab the URL. It would be test, but I'm going to use this one to show the step. I just copy the URL. I go into RStudio. I go up in the corner. I say new project. Wait. Okay, that took a long time. Okay, then I click version control, Git, paste it in, and I do need to look here what the name is. Fine, I'll call it new repo, and I do need to look at where I am going to save it. So all of my repos that come from GitHub will be in a folder called GitHub. If they came from GitLab, they would be in a folder called GitLab. That's how I organize it. Yes. Okay. So that's it. So now I have that repo onto my computer. So this workflow where you create what you want to copy onto GitHub or GitLab, you import it there, and then pull it into your computer, what that tends to do is it tends to prevent these problems where your computer, your local computer, can't authenticate. It doesn't, or it has like it's pointing to the wrong remote repo. And those kind of problems, they'll happen every so often. They tend to drive you crazy. So I always use this workflow just because I don't want to waste time trying to deal with those authentication problems that come up. Authentication just means that like can't figure out the right password, or it's pointing to the wrong repository. Okay, so that's how to get somebody else's in a really robust way. What about if you want to make a copy of your own repository and you want to use that as a template? So I want to show you a way that you can do that. That again is going to tend to not cause headaches. And I say this because this thing, you would think it would be so simple just to make a copy of your repository and use it as a template, and it not, you won't suffer a lot. But after suffering quite a bit, I've learned that it's not true. It can cause a lot of problems, and I've settled on this particular workflow. Okay, so first thing, what I'm going to do is I'm going to create a blank repository up on GitHub. Okay, so here we go. I'm going to do plus, and I'm going to say new repository, and give that a name. I would give it the name that I actually wanted to use. Here I'm saying test, but I'm not going to use in real life. I wouldn't do like a fake name like this. I'm going to call it, species distribution, whatever. Okay, but I give it a name. I don't need to give it a description, but I do need to initialize it with a README. And I am going to add a git ignore. I'm going to create that. Okay. So now I have this blank repository. And now I want to pull that in. So remember, I go here, I copy the URL, copy. I go back to RStudio. I know this is a lot of steps, but trust me, after you do it a few times, it just becomes second nature. Keep the instructions out in the beginning, and pretty soon it'll be second nature. So I've created the repository. Yeah, that's a good question. I'll get to that question later. Go to version control. Boom. I paste that in. Okay, and I create. All right. So now I have this blank repository, and now I can get the files that I want into that. So let's see. Okay. So why couldn't I just clone this existing repository? So as the notes on the website say, this is in the situation where you're using it just as a template. This is something like you often want to do, and you don't want the history of that old project. You don't want anything about the Git repository part in this old project. You just want to use the files because you're going to build off that. You're going to completely change them, but you're not going to totally change it. So that's why you're copying it. Okay, so let's see. I want to use something that actually has files in it. Which one? Okay, I'm going to use this one. This is actually massive. This is a public repository that I have. But I want to copy a few of these files that I'm going to use in this new repository. Okay, so I've got one folder window there, and then let's open another one. So I'm just opening up two here. Documents, going back to GitHub. And now I'm going to open up this test repo 2. So this is that blank one. All right. So this is the repo, the existing one that I want to copy over. Not all of it, just the parts that I need. And the key thing here is this .git folder. That's what you don't want to copy if you're trying to sort of make a duplicate of a repo that you're going to build off of, because that has the history, and more important, it points to what the remote repository is. And in the beginning, I didn't realize the importance of that git.git folder, and I would just copy that over. Or I didn't have my folder set so that I could always see this hidden file, and I suffered a lot. So just be aware of that. Like when you're copying, if you're doing this, you're just trying to steal some material from another repo, you want to leave this alone. Don't get that. So I could take what I want from this, maybe I want, description, and I'm going to make sure I just copy over whatever I want out of here. So if I wanted everything, I could copy everything. Right? Key thing is I'm not going to select that. So that's it. I've stolen whatever I want from the existing repository that I'm going to build off of. And now, when I go back here and I look at Git, I see this stuff. And so I can go ahead and select that. And then I commit it. Repo. First commit. Okay, so notice that I've done 3 steps here. I clicked those little buttons to stage it. What that did is it said, okay, hey, these are the changes I want to assign this little comment, this commit to. And then I click commit. I added the comment here, so that was step 2. And now I've done that. It says up here, my branch is ahead by 1 commit. That means on my computer, I've committed a change, but I haven't pushed it up. Origin is the remote. I haven't done that yet, and I'm going to push that. So now I push that. All right, great. So that worked. All right. So that is a workflow when you want to make a repo that's a duplicate of an existing one, but you don't want to have any of the history of the old one. You're just building something brand new and you want to use it as a template. Okay, so let me get to some questions. First off, what is .gitignore and what is its purpose? Great question. Okay, so let's take a look at it. I'm just going to click at it. And so the things that you have on your remote repository, those are the things that you want to pull into your sort of all your computers that are using this. And imagine you're on a team. There would be the files that everyone is pulling on their different computers. Well, there are some files that are just they're local. So that means it's just local information. You don't need everybody to have that information. So here's the standard things that you would have in there. First off, your R history. What is that? The history is everything that I've typed. Have I typed anything? There's nothing here. Let's type something. So history is everything that I've typed on the console. So I don't want to share that with everyone, that then every time it would change, right? Their history is different than my history, and then like next time I pull down, I'd be pulling down their history. You don't want to do that. I mean, nothing terrible would happen, but it'd just be silly. Okay, same with your R data. That's the information about your session. So that's going to be whatever is in your environment. So right now I just have A in my environment. And so if I sync that up, then everybody's going to pull in the other person's environment every time they they do a pull from the remote. So these are all things that you just don't want up on the remote. When you're starting, you can just use the default .git ignore file. RStudio will do that for you. Okay. Let's see here. Next one. Okay. The questions about, you know, like asking passwords to push and that sort of thing. Like if you're having, those are like authentication problems. Authentication is like getting username and password. If you go onto the setup and under help, you're going to see some help for how to deal with that. And then, of course, if you still have problems after looking at the help, stay on the line after the end of the workshop, and I can talk you through that. Okay, great. Let's go back here. I'm about to switch gears here. Okay, so I covered making your own repository. Okay, so just to quickly explain to you what these terms, branches, merge conflicts, pull requests are. If you want to use this, then use the link for that happygit.com, and it's going to walk you all through this. I recommend when you're starting to not get into branches and pull requests. Just let yourself get some experience with Git. Get really comfortable being able to work with it on your own for your own project before you start doing more advanced things. Okay, so but you're going to hear about branches. So what is a branch? So you think about like you have some code and you want to make a change. And instead of working on what would be called the master copy, you make a copy of that and you work on that. And so you can break that copy and nothing happens to the master. The master is still works fine, but you're working off on this branch that is a copy of everything. So it's absolutely identical. So you can make sure everything works. And then once you're satisfied, you can then merge that branch in. So the branch is like a separate place to work. It's a copy, so you can muck things up without messing up your main code. But like I said, when you're starting, just work on the master until you're comfortable. Okay, pull request. A pull request would be a situation where typically it's going to be where you're working with a team and somebody wants to make a change to your remote repository, and instead of just like pushing it in there, maybe they're allowed to anyhow, they put in what's called a pull request. And then you'll get a notification and you can review whether you want to pull that in to your repository or not. Merge conflicts happen when there is a conflict with what's on the remote repository that you're trying to pull down. So there's some change that's been made to the remote, and then you have a change on your local computer and they can't match up. One of them is going to blast the other, and Git doesn't know which one you want to use. I'm not going to talk about how to resolve those right now, because that's a long topic. You'll see that if you go on to Happy Git with R. I will say that if you use GitHub Desktop, it has a nice feature where it will ask you if you want one or the other. So it could be that you want a little combination of both, what's on the remote and what's on your local computer, but oftentimes you know exactly which one you want. And in GitHub Desktop, you can select, yeah, no, I want that one, just that one. Blast out all the other changes. So that's a nice feature of using GitHub Desktop. Okay, so yeah, I'm not going to go. Oh, I will talk about what is fork versus clone. So you'll notice if you fork somebody's repository on, say, GitHub or GitLab, you're going to still see, you'll be kind of connected to the parent directory. You'll see their changes, and you'll see how different the parent repository is from the one that you fork. And forking is usually used when you're in a team and you need to make a copy of a repo. You're going to make some changes, and the idea is that you're going to merge those changes back in with the parent. If you have no intention to do that, you just want to make a copy that you can work on, then you would clone it. All right, okay. So we're half hour in. I am now going to switch gears and start talking about coding. Like I said, I'm going to stay on at the end, and I'll answer your questions about working with Git. And you can also contact me over email. But again, if you're having issues with like getting everything connected, look at the setup and the help part that might answer your questions. And then again, if you do have questions as I go along, just throw those into the chat. I'm going to work through those as I go. All right. So now we're going to completely change gears, and we're going to talk about code organization. I'm going to kind of talk at kind of a high level here. So on the front page of the website, I introduced a little bit about what I do. You know, that I code a lot with R, but I also code things that are intended for the public and that need they get a lot of exposure, but I also code things that are used in CRAN, and I have one package in particular that is really heavily used. One of the, I don't know, top 1 or 2% of packages on CRAN. People use this for their statistical analyses, so it's you know, it's really important that that code is very robust. But it also means, you know, I have a lot of experience with these large coding projects, and I've also helped people who have given me, you know, or have joined a team, and like I can go through their scripts, and then I help them, or help the project, really help the team take that R code, R scripts, and then develop that into something more robust that the whole team can use. And typically, maybe always, what I'm doing is I'm developing an R package. And we're going to cover that in weeks 4 and 5. But these ideas about core code organization apply whether or not you're developing an R package. Okay, so so R is object-oriented, and this is really important to know if you're working with R. This is going to affect everything about how the things that you develop, the objects that you make. An object would be something like, you know, A equals 1. A is an object in this case. So what does that mean? Okay, so if I were to do a linear regression in R, and so here I have just fit, LM, dist versus speed, data equals cars. So this is the cars data set. If you go onto the R command line, you type cars, you're going to see something with distance, or with dist and speed. Do a linear regression. And if I do the class of that, then it says it's class LM. And because of that, R, quote unquote, knows what to do with objects of this class. So there's all kinds of functions that will use that information. So for example, coef, which is getting coefficients. So that function coef, what's happening in the background is that there's this function called coef.lm. R looks for that, and then it uses that function to decide what to print out. In this case, it's looking for the coefficients in the fit object, and then it has a little, a print function that prints it out like that. So your print, there's a print.lm, there's a plot.lm, there's all these functions. And, okay. If we look at this thing lm, what it actually is a list. So if we said names fit, it has all these other things, and it's just a list. And a list is like a bunch of buckets, and in those buckets we can put whatever we want. So we'll hit coefficients, which is probably, not sure what it is, maybe it's a vector. These are different things. Some of them are matrices, some are data frames, some are formulas, all kinds of different. You can put anything in a list, anything in your buckets. Okay. So so one other comment here about this of how this, the fact that things are objects is being used is like when we call lm, this thing here, cars, is a data frame, and lm recognizes that, and then it knows what to do with it. So it knows that, that's a data frame. Okay, and then it knows that these things here are columns within cars. Okay, so as you're developing as an R programmer, it's important to start moving towards an object-oriented mindset. This doesn't mean that you use objects in your coding. Although if you're someone like myself who's developing R packages, I'm using objects all the time. I create my own objects. It's essential to what I do. But an object-oriented mindset is it's just starting to think about your code as blocks, and blocks that are kind of independent. Okay, so let's sort of, I'm going to show some examples of what I'm talking about here. Okay, so let's go on to salmon.r. So this is just some code, and what I did was I wrote up a script that would be kind of typical for something that I might get from somebody. Coming into a group, and there's a lot of code that have been used for the analyses, and this is kind of a simple example. So this would be their script. It's well organized, it's commented, I can absolutely follow along. We have this set working directory, and it looks like this person uses both a Mac, so this would be on a Mac, but they've also set this up in case they're on a PC. They've commented it out because it looks like they were probably running this on their Mac when they gave it to me. Then they've got this section here for reading in the data. Then they have this thing they're creating, they're testing and training data frames. Then they're going to fit, and then they're going to make some plots. Okay, so that's fine. It all works. The problem is that as this project gets much more complex, we're doing more and more things, we're going to run into trouble if we just keep working in a script. And we're going to run into trouble if our data files start changing. Or we change how we do our fits. And the reason is that we're going to run into trouble is like our scripts are quickly going to get hundreds of lines long. And we're going to be like copying this fit code over and over again. And you've all seen scripts like this. We've all developed scripts like this. Anyone who's programming a lot, you know what I'm talking about. You get this long script, and you keep copying the code in different places. And that working like that is going to lead to code that's not robust, and it's going to make you very inefficient. So you have to move away from doing that. And now you're in the position where you've got kind of a bigger project. And at this point is when you need to step back and start developing this object mindset. And so what you're going to do is you'll think about, okay, now I'm thinking about my code, but I'm doing it like this cartoon. And so what I want to have data objects and fitting objects. I'm also going to have probably prediction objects for the example I'm showing. But let's just say right now we have these two objects, a data object and a fitting object. And what I want is I want to create a data object that has all the information, so I can just pass that to my fitting function. And my fitting function is going to create a fitting object. And if I have that fitting object, I know everything about it. So I know what data it used. I know what fitting function it used. Everything about it. And when I want to plot, I can just send that fitting object over to plot. And I don't have to know other information about the data. So let's an example of that it's going to come up all the time if you're not thinking of things with an object-oriented mindset, is like when you want to plot, your plot routine is going to have the fit, it's going to have the title, which maybe you've hard-coded there, it's got some things from the data, maybe you've cut your years, your fitting object didn't have enough information to do something with it. Right? You had to pick all these things from other places, and that process where you have to rely on something outside the fitting object to plot is going to bring in errors and inefficiency. So this mindset is trying to kind of think of things as these chunks that are independent. And I'm going to show you how you move in this direction. Okay, so when you think about an object, what is an object? So what you want to do is what is an object? It has a standardized form. If I say a data object, I can describe that. So I can say the data object in my project is a data frame, and it has these columns and has these column headings. And I'm going to force myself to use a standard format for my data. And second thing, that object, here's a key thing, that object has all the information that subsequent functions might need to use this object. So, like, think about how that's different. So how many times you create some data, and then 100 lines later, you're using dat, right? Okay? And you're like, wait, what is this? Where did this, wait, is this the right data, right? It doesn't really have any information with it. Maybe it has the same column headings, but you can't remember, God, which file did this come from? And you're working on a big project, that is going to cause suffering. So if you think about things as a data object, this object has both the data, but it also has like metadata, where you know where it came from. You're not going to run into those problems. Okay. All right. So what I expect you're thinking now is like, how on earth are you supposed to do this? And if you're also thinking, you know, is it even worthwhile? I'm not so sure about this. That's totally understandable. But I will say, as someone who works on big projects, that taking an object-oriented mindset is absolutely crucial. So thinking of things as these building blocks. Okay, so how do you get started? You get started on a piece of paper. So you've developed quite a few scripts, but now you're like, okay, we're building bigger. Before you get too big, you're going to pull out the paper and start thinking. You're going to take, 15 minutes, half hour, and think about, okay, my data. What would the data look like that is going to come in? What future data types might we use? You don't want to be painting yourself in a box with your code that your code can't work with the types of extensions that you expect. And then think a little bit about what should the output look like. Well, what am I going to do with this data? I want to make it easy that I can work with it. In this data planning stage, I would say don't go for perfection. Do not try to deal with every eventuality that you might come up with. Right? You're trying to get your work done. You're not trying to create a workflow that prevents you from actually getting anything done. But spend a little bit of time thinking about it and coming up with a plan. And this thing here, like column names for your data, is so important. I can't tell you how many times I come onto a team, project, and I've got data, and one of them they're using, all caps year. The other one is year, no caps. The other one it's, brewed year, but it's not really brewed year. It's actually just year, and it's the same project, and we all have the same data, and all the column names are just a little bit different, and it just creates a mess. And if you just, as a team, decide on something simple like that, it will really help you out. Okay, so like I said, don't get stuck on perfection. Get started. As you get more experience, you'll get this will go faster, and you'll figure out what form you should have for your data. Great. Okay. So so you do the one you plan, and then secondly, you're going to start putting your script into categories, and you're going to write functions for that. So let's look at an example back at salmon.r. Okay. So here's our script. What do I mean by categories? You're going to grab this part, which is they've nicely documented this for me. What's all the stuff with data? Okay, so that is going to go into a function for data. So that's pretty easy. And then we've got this fitting part. Okay. And now we want to think, okay, we want to have a fitting function. And here would be, at the bottom, what might be an example of that kind of fitting function. And so I need to think here, I need to look at this code and think about, okay, what kind of information do I need here? Well, actually this part where we created the testing and training, that's kind of part of fitting, and there's a decision here about the years we're going to use for training. Okay? So we're going to take that and we're going to think a little bit and make this fitting function, and I can, say what the response variable is, covariate, and then I can say what function I'm going to use. This isn't particularly, pretty code or anything, it just gets the job done. But now I've written this fitting function. And then later when I need to fit, I'm just going to call this. And the reason this is going to make your code a lot more robust instead of copying is that if you decide to change something a little bit about your GAM, say you're going to fix the flexibility of this GAM, you can put it in this function, and then you don't have to go through and search everywhere for your GAM and change, the smoothing function of that. Or here, I decide, oh, for my linear regression, hey, actually, I don't want to intercept. So those sort of things. So it's really simple. Like, it's not, it's not super hard. But just forcing yourself to think about this as these building blocks really will make a difference. Okay, so, all right, so that's how you get started. I give some more examples here of how the kind of building blocks that you might use, and you just kind of push yourself towards that, right? Push yourself away from these long scripts, and also push yourself away from making things like, read data 1, read data 2, read data 3. Step back, think, okay, what's all common about these? How do I create one function? So whenever you find yourself in a situation where you're doing a lot of code duplication, what that means is you're copying and pasting, right? And you're kind of going into a danger zone. Try to move away from that. All right, a few more minutes here. Okay, I want to talk about namespaces. So another thing you might not have thought about, but that can really, really mess you up if you're in a big coding project. Okay, so every function in R belongs to a package, and unless you wrote it yourself on the command line, right? So these are functions that you didn't write yourself. It's going to be part of a package. And to be 100% explicit on how you call that, you could use the : So this right here would be the forecast function within the forecast package. Okay, so why does that matter? What are some of the effects of that? Okay, so if you have the Dismo package loaded, if you have the Dismo package installed but not loaded, and Dismo is something for species distribution modeling. If I did question Dismo as a function in that, it wouldn't show up. But R knows about it. I could do question Dismo : and if I did that, the help window would show up. So even though a package isn't loaded, that means you haven't called library Dismo. It's still installed. Okay, so why would you possibly care? So the reason is that really disastrous things can happen if you don't know about this, if not aware. Okay, so in R, R will allow you to create functions that have the same name as a package. And you can sort of accidentally get rid of access to functions. Now, let me show you an example here. I'll just walk through this code. Okay, so AutoArima is a function in the forecast package. And I could run this code right here, AutoArima function x equals x, and I could sort of reassign that function. And so I did that someplace, in my somewhere in my script. I just happened to do that, and now I want to use AutoArima in forecast, and I do library, and I'm not really paying attention to this part, but it warns me that I have just masked AutoArima by something that's in my global environment. And now if I type AutoArima, I just get this string here, which is what my function was. So I've just gotten rid of that. And I will have to remove it from my environment, and now it's going to use the forecast auto-arima. So now it fit that auto-arima. So when you're you're working on a really big code project, it's important to use that ... for your functions, so you can prevent that from happening. It doesn't happen very often, but when it does happen, it's a bug that is really hard to find. And also, if you're sharing code, you have no idea what's in their environment. So you have no way to predict if they've created this function that's going to blast out this other function you need. The second reason is that if you are working on a project that are using lots of packages, if you share your code, if you use the ... it's going to show them exactly where that function came from. And that is super important for readability of code. Okay, so last thing, I'm going to do some kind of various quirks about R. So these are some tips. Don't want to do that. I want to jump here. Okay. Okay, great. Here's my tips right here. Okay, so one is your working environment, I would say, is your enemy, and you're going to need to keep it clean. I often do remove list.ls. That's going to blast everything. It's danger. You don't want to. It is going to blast everything that's in your environment. So if you got this simulation that took 2 days to run and you haven't saved it, it's going to get rid of that. But also a tip that you can use is to use R Markdown files to run your code, and that will run with a clean environment. It's amazing how many times you discover that you were inadvertently using something in your environment in your script. And so you either discover it when you run your script in R Markdown, or you give your script to someone and they come back and they said, hey, food doesn't exist. And you're like, oh, wow, that was using something in my environment. And that also can create these bugs that are really hard to track down because you don't realize that it was using this wrong value that was stored in your environment. Okay, another big tip is to use class to figure out what R thinks objects are. Unfortunately, R will change the class of your project, of your objects to be helpful. And I'll show you an example of that in a moment. Okay, so another thing, the kind of weird thing about R is that data frames are lists. They're not matrices. They look a lot like matrices, but they're not. They're lists. And this can cause some weird things, like this operation down here that you think should work. It's just a matrix operation that doesn't work. This might seem kind of like a random grab bag of problems, but having worked with a lot of people, these are kind of my top 10 things that people will give to me, and they're like, why doesn't this work? And they don't realize how important the fact that R is object oriented, how important that is. So this, I'm not going to go through all that. It just gives you some examples. Factors. Let me just jump, give it a time to. Yeah. This part, that it's really important to know if you're coming from another programming language, that R will change the class on your project silently. This is really horrible and really shocking to people who come from other programming languages. And this will cause really frightful number of bugs and errors. The way to deal with this is, again, using the class function in R to figure out what's happened. So that's like the first thing I'll do. If I'm debugging, I make sure I know what the class is, because R will silently change class. So here's an example, like with a data frame. And here's a nice little data frame. And I just wanted to do this apply function. I'm going to apply to A, to the columns. And I just want to take the first two elements of that column. And here's the output. And you can see there's quotes around it. It's like characters. What on earth happened? So this is just an example of something mysterious that happened and that R didn't warn you about. It needed to transform your data frame to a matrix, and it silently did this. That can cause a lot of problems. All right, so it's 11 o'clock. I'm going to stop here, and I would skim through the examples I show here of bad things that can happen. I think it's really important if you're doing a lot of programming, just skim through these like top 10 horrible things that can happen in R, and it'll save you a lot of time. All right, week 3, what I'm going to do is I'm going to be switching gears again. I'm going to talk about R Markdown, how we can use that for reports at NOAA Fisheries. But I'll start off with showing you some helpful debugging and benchmarking functions. Benchmarking means figuring out how fast your code is. All right, so I'm going to stop there and take questions. Oh, and I see there are a bunch of questions. I didn't realize that. Okay, great. Okay, so if you need to go, go ahead. I'm going to start working on the questions. And right after this, when I get video, I'm going to post that video so you can review the material. And then as I get questions, I'll also add that into sort of FAQ for the session. So hopefully the questions I answer will be helpful to you. All right. Hope to see you next week. Again, we're talking more about R Markdown, a little bit about debugging. And now I'm going to go and plug away at these. Okay. So, all right. Okay, so question. Do you keep all your repos in your GitHub folder, including your own and copied ones? Yes, I do. What about private repos? Okay, I have 2 answers for that. First, I'll answer that as like if I were in academia, okay? Then I would say, yes, my private repos would be in that folder on my laptop. You don't have to call it GitHub. I just organize it that way because I'm using both GitHub and GitLab. And I need to figure out, where did this come from? I don't want to have my GitLab repos mixed in with my GitHub. And I definitely don't want my repos scattered all over in different places in my computer, because I would never be able to find them, and I have to get to them and work on the files. Okay, so now let's answer this as a NOAA employee. So GitHub for us as NOAA employees is for our public projects. So it's intended to be something public. And that means, so remember, GitHub is not on a NOAA computer, it's not a NOAA server. And so we can't have data on there that's not supposed to be public. And so we have our GitLab, internal GitLab, that's on our own computers, totally private, and we can use that for anything. And so those GitLab folders and our internal GitLab, I will also have in my GitLab folder on my computer. Okay, what is the rproj file? that is the information about your RStudio project. So you don't generally want to push that up to GitHub or GitLab. Okay. With embedded comments and highlights, how to deal with that? Not sure what that is. Someone asked about reading XLS, Excel. Yes, you can. Somebody posted a link to the package. That's great. I was working for a while importing Excel files, and I found that the packages just kept changing too often, and it was too much work maintaining my code so that it would properly process Excel files. And so that's why I work now just with .csv. So people have to save it as a .csv, but at least I don't have so many headaches. Is there a way to remove all packages at once? There probably is. I don't know why you would want to remove packages. But if what you mean instead is I want to unload all my packages, yes, there's a really easy way to do that. And that's a really cool thing in RStudio. So I'm in RStudio, and I have a whole bunch of packages loaded, and oh, I can't remember how many I have, and it's causing me a headache, or R is just acting weird. I go to session and restart R. It's great. Did it fast. It unloaded all those packages. So the packages are still installed. They're just not loaded. So like if I do library forecast, I'm going to load the forecast package. And now if I do question mark auto arima, it's going to show up in the help window here. And now if I do session restart R, now I do it. It doesn't know about it. Right, it got rid of that. It didn't get rid of the packages, just unloaded it. So that's a really nice feature in RStudio. Okay. Okay. Unloading all packages. Yeah, so that StackFlow one, that is, again, that I didn't click on that. My guess is that they're giving you a command line answer, but if you're working in RStudio, just do restart R. Okay, someone asked here about, can you talk about R script organization? Do you keep your functions and code, which actually call the functions, separate? So a few different answers to this, depending on what I'm doing. So if I had a little script, a few hundred lines, 100 lines, and you know, I'm running this this sort of plot. I'm making certain plots over and over again. I'm going to have a little plot function at the top of that script, and I'm going to have to remember to kind of run those lines to create that plot function, and then I'm going to run plot. I'm going to call that. So that's how I might organize that if I just had one script. And I do this whenever I notice I keep starting to copy lines of code. I might copy the lines of code like once or twice, but after I'm doing it more than that, I'm going to stop myself and I'm going to write a little function. Because even though it feels easy, I know it's making me less efficient. And I just sort of fight against that inefficiency. Okay, but if it's not just a little short script, I'm going to have my my functions in separate files, and each function is going to be in a separate file. and then I'm going to call source. So, so I have my R script, and it's going to look like this. I'm going to do, source plot fun.r, and plot fun.r is another thing, and plot fun.r just looks like this. Plot fun function. Obviously not that simple, but that's the idea. And then I'm going to save that as plot fun.r. And then here I'm going to source that. So that's how I would organize it with those source things there. And that keeps it really clean. I don't have to go searching for my functions. The last thing you want to be doing is like searching through a long script for your functions. Again, it's just really inefficient and sloppy. And then, like I said, I think I mentioned a few times, I often develop R packages. And whenever I start having a lot of functions, at that point, I'm going to go ahead and make myself an R package. I'm really comfortable with that, so that makes it easier. There's a lot of reasons why I might do that, but I'm actually only going to do that if it's a pretty big project. I've got a lot of functions, or I'm sharing this with other people. We'll get into why you might make an R package if you're sharing stuff with other people. Okay. So, I've got that specific question. Let me see here. I'm going to start from the bottom here. Okay. Private repos. For people not using but with a NOAA-associated GitHub account. You can pay to make it private. But again, just I warn you here, you remember it's on a non-NOAA computer. So it you definitely don't ever want anything on GitHub that is sensitive in any way. So like sensitive for us would be like, some data that is not really public. So even though it's made a private repo, somebody couldn't find it, you don't want to have non-public data up there, like commercial, fisheries data or something. Okay, so, yeah, okay. Let's see here. How to most easily install a new R version and reload hundreds of packages. For that one, definitely search on online. You're going to see lots of examples of that. And there's some very easy scripts that you can do that. And so for me, I don't do that. I install a new R version, and then I reload the packages kind of one by one. Well, they're not really one by one because they're kind of like there'll be like kind of groups of them that will load when I install something like ggplot2. That's going to get me a whole bunch of things. And I do that just kind of as a way to clean up because I tend to collect packages just as I'm doing research. And then when I reinstall R, it's kind of a moment for me to clean up my package space. Yeah, great. People are answering things. Super wonderful, wonderful. Okay, so question is like, if you clean your environment, do I re-import? Yes, so I'm going to have to do something and re-import things. If it's something big, I'm going to save it to an R data file and reload that. So throwing it out there, has anyone had issues with RStudio plus Git when interacting with files on the network? I often need to put in large data sets that are kept on the network. But it seems to make RStudio extremely slow when there is a Git file associated with my project. Okay, so to answer that question, if that data set is not a machine readable, so it's like our data file, then Git has to make a copy of the entire thing for its history. So think about it differently, like if your data set were like a .csv or anything kind of ASCII. Then if you made a simple change to that, the only thing that Git would have to store is that one line change. But if you're storing it as an R data file, then GitHub can't see that one change, so it's got to store the whole thing. And that may be the same with like Excel. So what you can do is, if you don't need to be pulling that back and forth, you know, thinking about having some things in like .git ignore that you're not pushing up to the remote. So like I'll do that when I work with raster files, huge raster files, not pushing that up to GitHub. I put those in .git ignore and just accessing those outside of Git. So you can always keep things out of Git using your .git ignore. I'll also say there that I do put a lot of things in my .git ignore that I just don't think that I need up on the remote repository. Okay, so let's see here. All right, okay, I think I have gotten through questions. Yeah, somebody answered this too about the R data and putting that into your .git ignore, and that is quite important. I'll also say that like if you're working with R markdown files and you have a cache, don't put those up onto GitHub or GitLab. That would really slow things down. Alrighty. Looks like we're good. Again, run into trouble, feel free to email me. I'll try to help you out. And I will see you all next week.